Hello everyone, welcome back to my YouTube channel. Today we're going to go over 9.1 perimeter and area and coordinate plane. So chapter 9, we only have 3 sections that we're going to go over, so this will go pretty quick, and it's about area and perimeter. So this problem says you and your friend have 2 choices for a wall decoration. You say the decoration on the top will use more wall space. Your friend says the 2 decorations will use the same amount of space. Who is correct? Explain. Well, you can see that we have these 4 little groups of rectangles here, and there's also the same 4 rectangles down here grouped together. So it depends on what you're thinking of as in terms of space. If you're thinking of space as area, then they are the same. If you're thinking of space as in length or width or height, then this top one is definitely longer than the bottom one. So it kind of depends on what you're defining as space, because if you're this one on the top will definitely take up more of your wall, because you can't really put things around it unless you want to, then it will look weird, but this is kind of a weird decoration anyway. But yeah, so area and perimeter and circumference is what we're going to talk about today. Perimeter and area are 2 different ways of measuring geometric figures. The perimeter, P of a polygon, is the sum of the lengths of its sides. So you can do that with any polygon, you're just adding up all the sides together. The area is the number of square units it encloses, so it's kind of like the area, the space inside of the figure. For the figures such as squares, rectangles, triangles, and circles, you can use the formulas for perimeter or circumference for circles and area. Okay, so here's the 4 shapes we're going to be looking at today. Square, to find the perimeter, you just add up all the sides. So side length of S, it's going to be 4S because the square has all the same size, so 4 times S. For area, it's side times side, or S squared, since the sides are all the same. For a rectangle, you add up all the sides, so base plus base plus height, since the 2 opposite sides are congruent. Or you can say 2b, because you have 2 of the b sides, plus 2 of the h sides, so 2b plus 2h, or 2 parentheses b plus h. So you could add these 2 together first, b and h, and then divide by 2. The area of a rectangle is probably the simplest one. You just do base times height, or length times width. Okay, a triangle, to find the perimeter, you just add up all the sides. There's not really a handy formula for that. So a plus b plus c. For area, you do base times height divided by 2, or 1/2 times the base times the height. And in this case, your height always goes from the base. So if this is your base right here, the height goes from the base perpendicular to the vertex, or perpendicular to the base and goes up to the vertex right here. Okay, so that's the height. The height is not this part right here. Okay, so the height always forms a perpendicular with the base, that right angle. So look for the right angle when you're looking for your height. And then a circle, your circumference. Circumference is like the perimeter of a circle, so the distance around the circle. It's pi times diameter. We always use pi when we're working with curves or arcs of sorts. Okay, so pi times the diameter. Diameter goes all the way across like this. Or you could do 2 pi times the radius, because the radius times 2 is just the diameter. So those are the same thing. So depending on what it gives you, you can either do pi times d or 2 times pi times r. And then area is pi times the radius squared. So if it doesn't give you the radius, you have to find the radius by cutting the diameter in half. Okay. The units of measurement for perimeter and circumference always are in linear terms, like inches, feet, yards, miles, centimeters, meters. So linear meaning there's no exponent. When you're doing area, they're in square units, so inches squared, or square inches, square feet, square yards, etc. We write that as the unit inches with a power of 2, inches squared. Okay, so now we have a rectangle CDEF with these vertices. What is the perimeter and what is the area? So the first thing I would do here is to graph and plot each of these points. So let's see, we've got, they should all be in the first quadrant because everything's positive. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. All right, so the first point C is at 1, 2, so over 1 up 2. That's here. C. 1, 6 is the next point, so up here, and that is D. E is at 6, 6. And F is at 6, 2. Okay, so here's our rectangle. Sweet. Some pretty straight lines. Good job, me. All right. So to find the perimeter, you just add up all the sides. So you can just count, and we know that this side right here is going from 1 to 6. So that's a distance of 5 there. Also 5 right here, because the opposite sides are the same. This one goes from 2 to 6, so that's going to be 1, 2, 3, 4, and 4. So to find the perimeter, we just 1, 2, 4. So to find the perimeter, we just add them all together. So 5 plus 5 is 10. 4 plus 4 is 8. So 10 plus 8 is 18. So your perimeter is 18. Area, in this case, we don't really have units, so I'm just going to say 18. Area, we do, it's a rectangle, so we do length times width, or base times height. So 5 times 4 gives us, gives us 20. So the perimeter is 18, the area is 20. Okay. All right, another one. So I'm going to let you try this one, because we just did this. And we'll talk about it in a minute. So pause this and try it in 3, 2, 1, pause. Alright, so for this one, that's what my rectangle looks like, HIJK, and my perimeter is 24, and the area is 35, because our lengths are 5 and 7. Okay. Alright, next, let's look at these circles. So, we can name a circle with a symbol, basically just circle with a dot in the middle of it, that's the center. So circle with center A is written as a circle symbol with A, so circle A. The formulas for a circle involve a special number pi. Pi is a ratio of any circle's circumference to its diameter. So to get pi, so if anybody asks you what pi is, the intellectual answer you would say it's the ratio of a circle's circumference to its diameter. Meaning you take the circumference of a circle and you divide it by the diameter. That will always give you this irrational number 3.1415926, yada yada yada. You cannot write it as a terminating decimal, so it doesn't end, doesn't repeat. You can approximate it as 3.14, or you can use 22/7 for pi. There's also a pi key on your calculator. So for an exact answer, you'll leave it in terms of pi, so meaning you don't change it to a number. You just say like 10 pi or something like that. But when it says to round to the nearest tenth, you want to put it in as 3.14 or 22/7 or whatever. Okay, so this one it says, what is the circumference of the circle in terms of pi, and what is the circumference to the nearest tenth? Okay, so if you remember circumference, we do pi times diameter, or 2 pi times the radius. Okay, in this case it gives us our diameter because it goes all the way through. So 15 is the diameter, so our circumference is just going to be pi times the diameter of 15, which I can say, if I'm leaving it in terms of pi, I'll just say it is. Hello, welcome back. I don't know when this paused, so this one right here was, your circumference was 15 pi, which came out to be approximately 47.1 inches. And this one down here was 8 pi, exactly, so that's the exact answer, centimeters, which rounds to about, I think it was 25.1. Okay, so this is the exact answer in terms of pi, so when it says in terms of pi, that's what it wants. This is to the nearest tenth here and here. Okay, cruising right along here. All right, now I have a triangle, so we need to plot this again. That's the first thing I would do, so you don't have to try and visualize it in your head. Oops. Very straight lines. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So our first point is at 3, 6. So over 3 up 6. That is E. F is at 3, -2. And G is at -3, -2. Okay, so we have this triangle here, and it's actually a right triangle because the sides are, the two sides are they're parallel, no, they are vertical and horizontal, so we know that this right here is going to make a right angle. Oh man, there we go, there's our right angle. Okay, so the nice thing about right triangles, or when they have horizontal and vertical sides, is you can just count the distance. So my length here from -2 to 6 is 8, so this side is 8 right here. Then from 3 to -3, this is 6. So I know those two sides. To get my third side, again, it paused. If you didn't catch any of that, I found 8 and 6 here and here, just by counting because they're vertical and horizontal. The 10 I found by doing the distance formula, which is this. So I used my points E and G, since I was looking for the distance between E and G there. So I did x1 minus x2 squared plus y1 minus y2 squared. Came out to be square root of 100, which is 10. So I have 8, 6, and 10. Add those together to find the perimeter, which gives us 24. To get the area, I actually only need the 6 and the 8 because of the right angle right here. So this right angle tells us where the base and the height are. So the base would be 6, the height would be 8. So 1/2 times 6 times 8 is 1/2 base times height, which gives us 24 also. So the perimeter and the area are actually both 24. Perimeter would be 24 units, area would be 24 square units though. Okay, here's another triangle problem, so I want you to pause this, see if you can graph it and figure out the area and perimeter. So I'm going to pause it in 3, 2, 1, pause. Okay, so we have another right triangle, conveniently, and our vertical side is 5, and a horizontal side gives us 12. So that's going to be our base and height because they form the right angle here. So to find the area, we're going to do 1/2 times 5 times 12, or 1/2 times 12 times 5, which comes out to be 30. To find this diagonal side, again, I did the distance formula. That came out to be 13. And when I added those together, I also got 30. 5 plus 12 plus 13. They will not always be the same. That's just happened to be that way in the last two problems. So it's pure coincidence. The area and the perimeter are not always the same with triangles, or right triangles, for that matter. So just turned out to be that way in this case. Okay, finding the perimeter of the pentagon. So for this one, again, we need to plot the points. So let me pause this while I plot these points really quick. Boom, there's your pentagon. All right, so we have three sides that we can just count, which is the BF, CD, and BC, because they're vertical or horizontal. So for finding the perimeter, we just need to add up all the sides. So I count up, this is 3, this is 3, this one goes from -3 to 5, so that's going to be 8. So then we need to find the diagonal sides. And it kind of looks like it's symmetric, so if we look at this, E falls right on this right here, which is 1, 2, 3, 4 units away from D, and 1, 2, 3, 4 units away from F. So actually these two sides right here and right here should be congruent. So we really only need to find one of those sides, and then we can just use it for both, since it's a symmetric polygon. So let's just do E and D. So looking at these 2 points here, E and D, if we can use our distance formula. So again, I do distance equals big square root. I'm going to subtract my x's. So 5 minus 1 squared plus, subtract the y's, 0 minus negative. What just happened? Cool. Okay, well, let's pretend that didn't happen. So what was it? We're doing E and D. 5 minus 1 squared plus 0 minus -3 squared. That gives us 4 squared, which is 16, plus 0 minus -3. That's going to turn into a plus. So 3 squared is 9. 16 plus 9 is 25. Square root of 25 is 5. Okay, so that side, we had our pentagon that looked something like this. Okay, that was really bad, but it was 8, 3, 3. Now we know that this side right here is 5, and because it was symmetric, this side should also be 5. If it's not symmetric, you would have to find the distance from here to here as well. But since ours was symmetric, we don't need to do the extra work. Let me just add them up. 5 plus 5 is 10. 3 plus 3 is 6, so 16 plus 8. So our perimeter is going to be 5 plus 5 plus 3 plus 3 plus 8, which comes out to be 24. Right, yeah. So perimeter is 24 of that pentagon. Okay, and then we have the area addition postulate, which says the area of a region is the sum of the area of its non-overlapping parts. So for example, this is not a rectangle or a triangle or something nice. It's a combination of a bunch of things. So what we can do is we can split it into different pieces. So I can split it there, and I can split it there. There's different ways you can split it as well. But I know that these little tick marks right here and right here, that means that all those sides are the same. So all those are 3. Okay, so this is actually going to be a square here because it's 3 by 3. Oops. Back. So all these things are 3. Okay, and then this has a double tick marks. So that means those two are going to be the same. So that means this is 9. Okay, so the area of this first part right here is just 3 times 3, which is 9. The area of this one is going to be 3 times whatever the length is here. Because we know this whole length is 9. Now this length right here is 3. That means this has got to be 6, because 6 plus 3 gives us 9. So 3 times 6, that gives us 18 for that one. And then 3 times the whole length of 9 is 27. So we can add all of those together by the area addition postulate. So your area is 9 plus 18 plus 27, which is 54, and this is in centimeters squared, or square centimeters. So that's D. Okay, last one. Okay, so this one we need to split into different shapes. So I'm going to let you try this, and then we'll talk about it. So pause this in 3, 2, 1, pause. Okay, so I split this one into the rectangle and then the triangle. The rectangle is 12 by 4, so that gives us 48 square feet here. The triangle, so I know that this side is 4 because it's equivalent to that side because they have the 1 tick mark there. And then I figured out this side is 8 because I know the whole length is 12 here. And then this piece right here is 4. So 12 minus 4 gives us the remaining 8 there. So to find the area of the triangle, we do 8 times 4, which is 32, but then we have to cut that in half. So 1/2 times 8 times 4 gives us 16. So we do 16 plus 48 to get 64 square feet. And that's all for now, folks. I will see you guys later. Please take the quiz. TTFN.